So I'm going to take a quick look at the Lab 6Q3 for this week. And there's a few concepts that we should keep in mind when working this. This lab is about confidence intervals. And we're going to need to calculate first p-hat. And p-hat is just going to be the proportion of American bullfrogs depending on the sample size. So the p-hat for sample 1 is going to be 68 divided by 120. For sample 7, it's going to be 70 divided by 120. If we change over here, it's going to be 84 divided by 180, and so on. So that's p-hat. And the purpose of a confidence interval is to roughly estimate where p, the proportion of American bullfrogs in the population, is going to be. Because usually we don't know p. We know p-hat, but we usually don't know p. In this case, p is given to us for the purpose of checking if our confidence intervals are working. But we actually don't need to know p to make our confidence intervals. And a confidence interval, the purpose of a confidence interval, is simply to say, well, we have a p-hat, and it's very likely that our p-hat most of the time is going to be relatively close to our p, the true proportion. It's going to be relatively close, but it's not going to be quite there. It might be lower than p, or it might be higher than p, but it's mostly going to be very close. So instead of saying, well, p is going to be most likely, the true proportion is going to be most likely a set value, 0.56, we say, well, our p is very likely to be within 0.4 and 0.7. And that's a confidence interval, a range. You're saying, well, I'm this percentage sure that p-hat is actually going to be within this set range, this set confidence interval. And you do that by extending a range to the left and extending a range to the right. And this area right here and this area right here is a margin of error. Okay? You add your margin of error to p-hat to get your upper bound, and you subtract the margin of error from p-hat to get your lower bound. That's how a confidence interval is created. But how do you get your margin of error? We know now that the confidence interval is simply a set of two values, a range, and you take p-hat and subtract or add to get your confidence interval. But how do we get the margin of error? This is a formula. Before I show the formula, keep in mind that for the confidence interval to fail, the lower bound is actually going to have to be higher than our p, or the upper bound is going to have to be lower than our p. See, for this one, for this p-hat 2, the range does not include p. This is a failure. And we can check if it's a failure by checking if the upper bound is less than p, or if the lower bound is more than p. This one has a lower bound that is not higher than p, and it is fine. And its upper bound is not less than p, so it is fine. This was a successful p-hat approximation. Our confidence interval was fine for this one. To get our confidence interval, we get the margin. The margin of error has the following formula. C alpha over 2 times the standard error, which in this case is the square root of p-hat, times p-hat complement, which is 1 minus p-hat, divided by n. Okay, and this is calculated the standard error. This is the standard error. Standard error is calculated for each of these samples. We'll do it in a second in Excel. Our z alpha over 2, on the other hand, is a set constant depending on your confidence level. The formula for the z alpha over 2. To find z alpha over 2, you first need to find percentage z alpha over 2. And the formula for this is quite simple. It's your confidence level plus 1 over 2. Over 2. Your confidence level is what they ask you to form your confidence interval on. If you're asked to form a 95% confidence interval, your confidence level is 0.95. If you're asked to set an 85% confidence interval, then your confidence level is 0.85. So let's find the percentage Z alpha over 2 for a 95% confidence interval. It's going to be percentage Z alpha over 2 is going to equal 0.95 plus 1 over 2. That's going to be equal to 1.95 over 2, which is just going to be 0.975. How do we get our percentage Z alpha, which is 0.975, to Z alpha over 2? Well, we take this percentage and we look it up in our Z table. We look it up in our Z table, you'll find it right here, 0.975, and that has a Z value of 1.9 plus 0.06. So that has, we now know that our Z alpha over 2 for a 95% confidence interval is 1.96. 1.96. Let's find the confidence Z, the percentage Z alpha over 2 for a 99% confidence interval. So our percentage Z alpha over 2 is going to equal 0.99 plus 1 over 2. And that means that our percentage Z alpha over 2 is just going to equal 0.995. To find our Z alpha over 2, we just look up this value in our Z table, and we look up the value. We're going to run into a small problem right here. It doesn't exist. It's between these two. It's between 0.9949 and 0.9951. Right in the middle is our value. So what we're actually going to do, since it's in between these two, is we're going to get the Z value for 2.57 and the Z value for 2.58, and we're going to average them, and that's going to equal 2.575. So our Z alpha over 2 for a 99% confidence interval is 2.575. Now that we have the margin of error Z alpha over 2, let's go to Excel and calculate our standard error so that we can form our confidence intervals, which is p hat minus the margin of error and p hat plus the margin of error. So in Excel, this is the brand new sheet. I haven't done anything to it. The first thing we're going to do is format this as a table. We're going to hold Control Shift left arrow, Control Shift down arrow. We've selected the entire data series. We're going to go to Format as Table. You can select any format you like. There are headers right here, so you can leave My Table has headers. I'm going to quickly manipulate this. We're going to make our p hat. The reason I formatted as a table It's because there's quite a few benefits. The first is you can reference your table because this has a name. Your table has a name. You can go over here and select your table whenever you'd like by simply going over here. And you can go into table design and we can change the name. Let's set it to table 1 N120 so we can reference it later. Let's calculate p hat. And that's just going to be our B2 for every single one, this proportion divided by 120. That's a set value. And it automatically pastes since we're on a table. That's one of the advantages of having a table. Let's calculate our standard error. This is going to be sigma p hat or standard error, however you'd like to say it. Our standard error is going to be equal to the square root of p hat, which is right here, times, open parentheses, 1 minus p hat or p hat complement. Let me actually open parentheses here so that there's no conflicts, divided by n, which is 120. Close parentheses for the square root. So the square root of p hat times p hat complement divided by sample size 120. Again, it automatically pastes the formula. We now have our standard error and our p hat. Let's input the z values for 95% confidence interval and 99% confidence interval. So we have z 95%, we have a z 99%. I'll select both by clicking shift and I'll scale them both at the same time. Right here we have, let's remember that our z for z alpha over 2 for a 95% confidence interval is 1.96, and for a 99% confidence interval it's 2.575. We're going to use the equal sign because if we just put 1.96, it's not going to copy the formula down. So we'll put equals 1.96. Same thing here, equals 2.575. Excellent. Let's calculate now our margin of error. And I actually... Yes, okay. Our margin of error for a 95% and our margin of error for a 99% are going to be different. Scale these. Our margin of error for 95% is going to be equal to our z value for 95% times standard error as defined by the formula z times standard error. And for 99%, it's just going to be our z for 99% times our standard. Now that we have our margin of error for 95 and 99%, z for 95 and 99%, we can establish our confidence intervals. The confidence interval, we can start with a 95% confidence interval. Confidence interval for 95% confidence interval for lower bound is going to be equal to p hat minus the margin of error for 95%. Our 95% confidence interval for our upper bound is just going to be equal to p hat plus our 95% margin of error. Same thing for here. 99% confidence interval for lower bound going to be equal to p hat minus 99% margin of error, and our 99% confidence interval for the upper bound is going to be equal to our p hat plus our margin of error for 99%. Let's quickly double check these formulas. This looks fine. Now that we have our confidence interval set, let's actually make an indicator verifying whether or not our confidence intervals are working or they're not. So if we remember in our previous chart, the confidence interval fails when the lower bound is higher than P, 0.55, or the upper bound is lower than 0.55. And that's what we're going to do. We're going to set this as a failure if, that's this column, 95% indicator, 99% indicator. Let's resize. Okay. We're going to set this to 1 if our margin of error for 95%, not our margin of error, if our lower bound is actually higher than 0.55, it's going to return a 1 or a failure. Or, and we're adding this. We're adding this because if this returns it's fine. There's no problem. This is going to return a 0. And this is going to check whether or not the upper bound is lower than P, 0.55. If this returns a 0 and this returns a 0, then 0 plus 0 will be 0 and everything will be fine. If this returns a 1 and this returns a 0, going to trigger an error because of the lower bound. Same thing for the upper bound. But both of these cannot be true at the same time, so there will never be a 2. That's why we're adding this. Plus 1. And we're going to mark as a 1 if our upper bound is actually lower than 0.55. Let's double check that our formula works. And we can double check that because if we remember, our 95% confidence interval basically means that for 95% of these samples, this is going to be fine. So it's going to return a 0, which means that since this is checking for failure, for roughly 5%, very close to 5%, the rest of 95%, for roughly 5% of these trials, it's going to fail. So we can take the average of this column and we're going to reference it using the table we've created. If we remember, we called this table Table 1 N120. Press Tab, open brackets, and we're going to reference this column, 95% indicator. This is the column we need. We're going to press Tab again, close that bracket, and close the parentheses, and this is taking the average of this column. It is very close to 5%. So the indicator is working. Once we make our 99% indicator, we can double check if it's working, if it's very close to 1%. And this indicator is going to be tripped if our lower bound for the 99% confidence level lower bound is higher than 0.55, or if our upper bound is less than 0.5. We can double check if this is working by taking the average of that column. Same table for the 99% indicator, close parentheses. This is very close to 1%. So it is working. Let's delete this. We've now made all the columns we need. What we're going to do here is set up for the questions that we're going to resolve in a second. This is going to be the question number, letter. We're going to specify here what it's for. The answer, answer rounded, round 2. Let me open this. That. We'll format as a table, but we'll leave that be for now. Let's leave that. What we're going to do is do this same thing for all other samples. So again, Control-Shift left, Control-Shift down. It's format as table, format it how you like. My table has headers. Going to calculate p-hat. We're going to calculate the standard error. We're going to calculate the margin of error, 95% margin of error. We're going to calculate the 99% margin of error. We're going to input the 95% Z alpha. Not sure how we called it on this one. We just put Z. Okay. Let's keep it the same. And Z 95%. Z 99%. We can continue with our upper and lower bounds for 95% confidence interval upper bound, lower bound first. 95% confidence interval upper bound, 99% confidence interval lower bound, 99% confidence interval upper bound. We can also, are we missing anything here? Should be fine. We need the indicators. 95% indicator and a 99%. Let's start filling these out. We're changing this to 180 because we've changed sample size. Standard error is going to be the square root of p-hat. Let's open parentheses. P-hat times 1 minus p-hat, close parentheses, divided by 180, close parentheses. That's our standard error. 95% margin of error is based on Z, and that's just going to be 1.96 and 2.575. Can now make this 95% is just going to be 95% Z value times the standard error. Same for this, but with 99%. Our lower bound is going to be p-hat minus 95% margin of error, and this is going to be p-hat plus our margin of error. And I'm just navigating using my arrow keys. For our lower bound, same thing here, navigating with my arrow keys. P-hat minus our margin of error 99%, and our p-hat plus our margin of error 99%. This is going to mark true if, for the 95%, if our lower bound is higher than 0.55, something's wrong. And if our upper bound is actually lower than 0.55, there's a problem. Same thing here. if our lower bound is greater than 0.55, there's a problem. And if our upper bound is less than 0.55, there's so now we can check if our indicators are fine by verifying that this entire column averages out to roughly 5% for the amount of failures, and this column averages out to roughly 1% because of the errors. So over here, just going to quickly take the average of table 3. The column is 95% indicator, close bracket, close parentheses. Take the average of the table 3, open bracket, 99% indicator, close bracket, close parentheses. This is close to 1% and this is close to 5%, so that one is fine. Finally, we can do our n equals 260. Again, we're going to hold Control Shift, side, down arrow, format as table. We're going to take p hat. We're going to get standard error. We're going to get the margin of a 95% margin of error, 99% margin of error, Z 95%, Z 99%. Resize this. And we can get the confidence intervals. That would be the 95% confidence interval lower bound, 95% confidence interval upper bound, 99% confidence interval lower bound, and the upper bound, as well as the indicators. Gonna quickly resize this. And we can start filling this out. Sample size is 260 now. Standard error is gonna be the square root of p hat times complement of p hat, close parentheses, divided by the new sample size 260. 95% margin of error requires the z-value, which is 1.96, and 2.575. Yep. And now we can make our margin of error. That's just going to be 95% Z times the standard error, and 99% Z times the standard. The lower bound is just going to be p hat minus the 95% margin of error, and this is going to be p hat plus 95% margin of error. Same thing here. Okay, and this is going to mark 1 if our lower bound is higher than 0.55, or it's going to mark 1 if our upper bound is less than 0.55. This is going to mark 1. Same premise. if our upper bound is less than 0.55. Let's double check that our indicators are correct by taking the average of table 4, 95%. And the average of the table 4, 99% indicator, close brackets, close parentheses. Both are very close to 5% and 1%. So there should be no errors. Now that we have all of this established, we're going to quickly rename our tables to avoid confusing references. I'm going to go to table design. We're going to call this N180. And we're going to call this N260. Great. Now we can go back here. Now that we have all of our tables set, we can take a look at the questions. And the first thing is it's asking for the proportion of 95% confidence intervals that fail to surround the true value P for 120, 180, and 260, rounded to 443 decimal places. Just gonna write this down. This is for 1, 2, 3, B, C, D. Proportion of values that fail 0.5, P 0.55, or N equals 120. And this is going to be the same except for the sample sizes. The answer is just going to be, this one is going to be the average of the 95% indicator for the table 120. Let me specify that, actually. It's 95%. It's going to be the average for N120, open brackets, 95, indicator, close brackets. We're going to press Control Z so it automatically puts the values there. And let me just round this to this many digits. Great. This is going to be the average for this table, so we're just going to reference that, equals average for N180, open brackets, 95% indicator, close brackets, close parentheses. This is going to be the average for the 260 95% confidence. And 260, open brackets, 95% indicator, close brackets, close parentheses. Okay, great. Now we're missing these values over here. FGH 444. For these questions, what they're asking is probability for 99%, failure for 120, for 180 and for 260. And the answers to these going to be the average of these columns for all samples. So we're going to take the average of N120, open brackets, 99% indicator, close bracket, close parentheses. Going to take the average of N180, open bracket, 99%, close bracket, close parentheses, and we're going to take the average for N260. Great. These are all the answers for this section. So we've successfully finished the lab, and we have all data values set.